Hello everyone. In this video, I'm going to solve the aggressive cows problem, which is basically this problem. You can find the link for it and read it. In this video, I'm going to explain the problem very quick. Then I'm going to go through the solution. So let's start. The problem basically is like that. We have a farm, and in this farm, we have a number of stalls, like these stalls, these 5 stalls, okay? The stalls are located linearly beside each other, okay? And each stall has a number which represents the location for the stall. Also, we have a number of cows, and these cows are very aggressive to each other. So we have to assign the cows inside the stall so that the difference or the distance between each two cows will be as big as possible. For example, we have this example here. The input we have first, like the first input, we have two numbers, which is 5 and 3, which is represent the number of stalls, which is 5. The second number is the number of cows, which is 3. Then we have 5 numbers represent the location for each stall. So the first one in location number 1, the second one location number 2, we have 8 on location number 8, and we have 4 location number 4, we have 9 location number 9. And as you can see, the locations are not sorted in the input. So you have to handle this in your problem or in your solution. So after we know the location, we have 5 stalls, we have the location, we have the cows. It's better to calculate the distance. Here we have a distance, which is 1. Here we have a distance, which is 2. And here we have a distance, which is 4. And here we have a distance, which is 1. So we have to put the cows inside the stall and make the distance as big as possible. So here we can put the cow number 1 in the first one, and we can put the cow number 2 in the last one, and we can put the third cow in the middle one. Okay, so here the distance between these two cows is 3, and here the distance between these two cows is 5. So we need to find like the minimum distance between them, as they said. Like here, they said the minimum distance between two of the cows should be large as possible. So the minimum distance here between the cows should be large as possible. So this is the minimum one. So we are going to print 3, okay? Because we can't make 3 like better, like we can't make the distance better than 3. Like this is the largest possible distance, okay? So I will give you another example to understand it better. So we have this example. We have 4, which is the number of stalls 4. We have 2 cows, and we have 1, 3, 6, 10, which is the location. Here we have distance with 2. Here we have a distance with 3. And here we have a distance with 4. Okay. So we have 2 cows. So we are going to assign the first one here and the second one here, and the distance will be 9. So the minimum largest distance should be 9. Okay. So here we are going to print 9. And let's say that they are 3 cows, and let's make it 3 cows, for example. And here let's make it 3. So if they are 3 cows, what we are going to do is to put the first cow here, the second cow here, and we will calculate and we will find that the best one should be here, which is like if we put the cow here, then the distance will be 2 between this, and here the distance will be 7. So we have the minimum gap, which is 2. And if we put the cow here, then we have 4 here and we have 5 here. So the minimum distance is 4, which is better than the previous solution. So this is the true answer. We have to print 4. Okay. And if we have 4 cows, let's say we have 4 cows here, and here we have 4. Okay. So we are going to assign the 4 cows on the stalls, and the minimum distance is 2. So we are going to print out the number 2. So the question is that we have to assign the cows in these stalls so that we are trying to make the largest possible minimum distance between them. So how you are going to think about this question, or the tips that you have to consider so that you are thinking of this question in the right way. So first we have to know the goal very well, which is assign the cows to the stalls while the gap between them is large as possible. Okay, so what we are going to print is find the largest possible gap, like the largest possible gap between them, so that the minimum distance will be as large as possible. Okay, like as I explain it here. So another thing that you have to consider, that the input for the location is not sorted. So maybe we have to sort it. Maybe you can find a solution without even sorting them. The next thing that you have to know, that the cow's number is always less than the stall's number, which means that we always have a solution. We can always assign the cows inside the stall. Another thing we have to consider, which is the stalls and cows number is always less than 100,000, which is 10 to the power of 5. Okay, so when we solve this, we have to consider this number. I'm going to explain how to calculate, the possible answer for this number. And also we have a stalls location. So if we are going to use the stalls location, it is 1 billion, which is 10 to the power of 9. So we have to consider that this number 10 to the power of 9 in our solution. Like we have to consider these two numbers when we are going to write the algorithm. So how we are going to consider these two numbers, let me explain it here. So in any question, or in any problem solving question, 10 to the power of 8 is equal to 1 second. And usually we are going to solve the question with less than 1 second. Okay, so if we are going to use the number of cows or the number of stalls in our code or inside our algorithm, so the algorithm should be because we have 10 to the power of 5. So to solve this question with less than 1 second, we have to solve it with O of n, for example, or we have to solve it with O of n log n. Okay, so if we solve it in this time complexity, we are less than 1 second. But if we said that we are going to solve it, for example, on n square, so n square, which will give us 10 to the power of 10. And 10 to the power of 10 is way too big. So it will not, the code will not finish in 1 second. So n square is not possible solution. So we have to delete it. Okay, so if we are going to use the number of cows or the number of stalls in our algorithm, we have to solve it in n log n or less than that. Okay, also if we are going to use the stalls location, which is up to 10 to the power of 9, so we have to make sure that our code is will be with O of log n or less than that, because if we solve it with O of n, it's already 10 to the power of 9, which is bigger than 10 to the power of 8. It will take more than 1 second. It will take around 10 seconds. Okay, so this solution is not possible. So we can't solve it with O of n. We have to solve it with O of log n or less. So before we think about the solution, we have to know that if we are going to use the number of cows or the number of stalls in our algorithm, we have to use it with n log n or less. Also, if we are going to use the stalls location, we have to use it with log n or less. And now you can stop the video and try to think about your own solution. Then we are going to keep going with this video. So now, after you think about the question and hopefully you find a solution. Now, let me keep going through the solutions one by one and explain each one of them. So the first solution is brute force. And the brute force basically is trying every possible way that we in the problem. For example, we have this number of stalls, which is a 3, and we have 2 cows. So we are going like to try the like assigning the cows in the stalls without thinking about anything, without any condition, just to try all the possible solution and find the minimum gap, the minimum large gap possible. Okay. So what we are going to do, we are going to put cow number 1, cow number 2. The gap is 2 here, and the gap is a 3. So we will say the gap is 2. Then after that, we will delete this cow from here. Okay, and assign the cow here. And now the gap is 5, which is bigger than 2, so we'll say 5. And after that, we will delete this cow and put it here. And the gap is 3. 3 is not bigger than 5, so 5 is the printed answer. Okay, so in this brute force, it's basically like that. We are only going to try, like we have this cow and the other cow, and we are keep going, like assigning the cow in each stall, and each possible answer will be, and we will try it. That's it. So what's wrong with this solution? The wrong with this solution that because we are trying every possible solution, it will take a very long time. Let me explain it for you. So as we said before, we have like 10 to the power of 8 only to solve the question in 8 seconds. Okay, in 1 second. Okay, so we are using the number of stalls here because we are trying to assign the cows due to the number of stalls. So the number of stalls that we are going to use is 10 to the power of 5. And let's say, like for a small example, if we, for this example, let's say, if only we have 2 cows, so we are going to assign them to, like, let's say we also have another one here, which is 10. So we are going to assign here, then let me change the color. So let's try, like the first one is here, the second one is here, then the third one is here. Then we are going to move the first cow to here and try it to here and try it here. Then we are going to move it here and try it here. So what I mean, or what you are going to see, that we are trying to assign the cow for each one, which means like for every loop we are going to do it, like we are going to move forward and doing the loop again and doing the loop again, which means that we are going to try the solution with n multiplied by n, like in the worst case scenario. Okay, which is n square. So n here in our case, which is the number of stalls. So if we are going to use n square, so it will be 10 to the power of 5 and 10 to the power of 5, which is equal to the 10 to the power of 10, which is not a possible solution because it will take a very long time to run. So this solution will give us a time limit exceeded. So it's not a possible solution. Okay. Moving to the next solution, which is the linear search. What is the linear search and how it works? Okay. So what we know that for in this example, we have 5 stalls and we have 3 cows. And we are going to assign the cows to these stalls. Okay. So in the linear search, what we know that we have like the gap, like the last one is like distance number 9. And the first one is distance number 1. So we are going to say like the best distance that we can do is like the distance between 9 and 1, which is 8. So this is the best distance. Then after that, we will try 7. Then we will try 6. Then we will try 5 and 4 and 3 and 2 and 1. Okay. So we will start with the largest distance. Then we will keep minimizing the distance until we find the answer. Okay. So for example, let me start like that. So if we start with the gap, which is 8. So if the gap was 8, So we will like put the first cow here, then we will move 8 and we will put the second cow here, then we will move 8, but there's no any, like there's no any stall. So 8 does not work. So we'll try 7. When we try 7, we will put the cow, the first one, here, and we will move for 7, like 7 distance gap, and we will put the second one here. Then we can't, like if we move 7, there is no any stall. So we still need to assign another cow. So 7 is not a possible solution. Also, when we try 6, it will not be a possible solution. When we try 5, it will not work. When we try 4, let me try it, maybe 4 will work. So we will put the first one here, then we will move 4. Okay, so this is 3, this is like there is not less than this, so also 4 will not work. Okay, so let's try 3. So when we try 3, like this one, we will put the first one here, then we will move 3, we will put the second one here, then we will move for 3. There is no stall on number 7, so we will put it the next one, which is 8. So we will put the third one here, and here we have like a distance 4, we have a distance 3, and this solution worked. Like we could assign the 3 cows like in the largest gap possible. For example, like 4 did not work, so 3 is the largest one that's possible. So 3 like is a working, like it did work. So in this solution, we find the solution, and it looks really good because like we are trying to find the distance between the last one and the first one, and moving from the biggest gap to the lowest gap possible, so which is very good. So let's discuss this question about the time limit or the runtime. Okay, so as we said before, we have 10 to the power of 8 equal to 1 second. So we are using in this question the stall's location, which is like in the worst case scenario, the stall's location will be 10 to the power of 9. Okay, and if we say 10 to the power of 9, and the worst case scenario, the first one will be on 0. So we will say 10 to the power of 9 minus 0, which will give us 10 to the power of 9. So in our solution, we are moving from 10 to the power of 9, and we keep trying one by one, till we arrive to number like 0, or basically number 1, okay, which is the minimum gap. So when we tried 10 to the power of 9, it didn't work. So we'll move to the next one, 10 to the power, like we will keep moving one by one, till we arrive to the number 1. So basically, we are going to go through all the solution, which is O of n, if we think about it, like without writing a code for it, but it will be O of n. And n in this code is 10 to the power of 9. And it will be like O of 10 to the power of 9, which is more than 1 second. Like it's a bit more than 1 second. So this solution will give us also a time limit exceeded, because we are going through all the solution from 10 to the power of 9 to the number 1. Maybe we can find it here, but in the worst case scenario, we are going to 1. Even if we move in the other distance, like in the other way, the worst case scenario will be 10 to the power of 9, which is like in both cases, like it will be O of 10 to the power of 9, which is not very good solution. But like it's better than brute force, but it's not better, like it's not like a good enough solution, because it will give us time limit exceeded. Moving to the next solution, which is binary search. Binary search is basically almost the same as the linear search, but there's one difference, which is like when we were doing the linear search, like we were going from the biggest gap to the lowest gap, or in the other way, from the lowest gap to the biggest gap, which is moving linearly, like one by one. Okay, so in the binary search, it is a bit different. Like the difference here, as you can see, let me explain this, like this example to tell you what is the solution. So in this example, we have 6 stalls, we have 4 cows, and we have to assign them here. So we know that the answer should be one of these. Let me change the color here. Okay. We know that the answer will be like one of these gaps. Okay. Because like if we say like the gap number 1 is the lowest one, gap number 12 is the biggest one. So of course, the gap should be between 12 and 1. Okay. So we were searching linearly in the previous example. Now we will search as a binary. So as a binary, we will take a mid value, and this mid value will equal 12 minus 1 divided by 2, which is the middle one. So we are going to take the middle one, which is 7. Okay, and we will try to like the gap, which is 7. So we will put the first cow here, we will put the second cow here, and it didn't work. So gap number 7 didn't work. Why? Because the number of cows, like we have still 2 cows that we didn't assign. So we have more cows. Since we have more cows, then the gap is too big. Since the gap is too big, then anything bigger than 7 will not work. So we are going to cancel all of these, and we are not going to try all of these. So now we have an array from 7 to 1. So we will take the middle one between them, which is 4. Okay. So when we try 4, we will do it again. So we will try to assign the cows again with a gap distance, which is 4. So we'll put the first one here, then we will move 4 steps, which is like not this one. We will put it on the 8 because there's like there's no 5 here. So because there's no 5 here, we will put it on the next one. So we put it on the next one, which is 8, and we move also 4 steps. We will put it here. So 4 is also too big because we still have 1 cow that we didn't assign. So we know that 4 is big. So everything after 4 is also will not work. So we delete everything, and also we will delete the 4. Now, after that, we will try to take 2. Okay. What we will find out when we try 2, let me check. So the mid was the first one 7, it didn't work, then 4, it didn't work, now 2. Okay. So when we try it, it will give us that like the first one will be here, then we will move 2, there is no 3, so we'll put it here on 4. So we will move 2, there is no 6, so we'll put it here. Okay, so when we move 2 also, there is no there's no 10, so we'll put it on 12. So it worked actually. The number of cows is really like we put them in the right way. So gap number 2 worked. So what we know that gap number 2 worked, and everything before gap number 2 also will work. So we can say that from here everything before is working, and from here everything is not working. So we need to search like the middle area, which is number 3, because maybe 3 will be like a bigger minimum distance. So when we try 3, we'll put the first one here, then this is already 3, we will put it here, and this is 4, which is like because there's no 7, so we'll put it on 8, and this is 4 also. So the 3 was the largest minimum gap that we can assign, which is number 3. So what we know that the 3 is the answer that we have to print. So let's calculate this as a runtime, but let me explain it again. So if you didn't get it, like what is the linear research? So we have like these numbers. Okay, I will take them off. So what we find out from the linear search, when we try 7, we know that everything here is not going to work. And when we try number 2, we know that everything here is going to work. So we want to know like when the number are going to work and when the number are not going to work, and we will take the biggest number, which is a 3, which is our answer. So we try, this is not going to work, this not going to work, and here we find out that from 3 it's going to work, and from 4 it's not going to work. So we will take the biggest gap, which is number 3. Like basically this is the solution. So let's go to the calculation for it. We are using the stalls location as the previous one here. We were using the stalls location. So to calculate it, we are going to say, like, because it was a binary search and we were eliminating in each step like half of the input. So this, the binary search is like taking like log n, because in each step, like this is the array, in each step we are eliminating a half, then we are eliminating another half, then we are eliminating another half, like leading us to the final answer. Okay, so this means like each elimination we are taking half of the input, so which means like it will take a time complexity with O of log n, which is a very possible solution for this number because it's 10 to the power of 9. So when we assign it to the log n, it will take like 9 operation, which is the very, very fast solution. Okay, so let's write a code for that. So now we are going to write a code for our problem. And writing the code, we have to keep looking for the input and the output and the condition for our problem, so that we are writing the code in the right way. So when we read the input, the first thing is like a number of the test cases. So we have to write down like integer n, then cn for the n, which is the number of test cases, and then we will say while n minus minus, which is to the number of the test cases we are going to do our algorithm. Okay, so our algorithm is like that. Inside the while we are going to work, we have two numbers, which is the number of stalls and the number of cows. And also after that we have an array, which is the location for each stall. So what we are going to do here is that we are going to write like integer, let's say stalls and cows, and we will make an array, let's call it location, and it should be like to the, this is 2, also we need another 0, so this is 100,000. No, this is bigger than that. So this is 100,001, which is all the location plus 1 location. Like we make an array with the largest possible, with the largest possible location. Okay, for all the stalls. You can make a vector, for example. You can say like vector of an integer, and you can call it location. And here we can include a vector, and for each time we will say like vector dot pushback, like locate dot pushback, and we will add the numbers, and it will be a very accurate. But like I don't like to use it, I like to use the array, so I'm going to keep going with my solution using the array. Okay, like the difference when you use the array or vector is one thing. So for example, in the array, when we assign the input, we have 1, 4, 6, 8, for example. Then after that, we have rubbish value. So we have to know, like for example, if the input is 10, like we're only going to use 10 locations from the array. So after that, everything is rubbish value. So we need to know, or during our code, we have to make sure that we are only working on this part of the array. We are not working on all of it. But if you are going to use the vector, don't, like, you are not even going to take a rubbish value. You will take only the needed value. So anyway, I'm going to use the array, so I have to make sure that I'm going to work only on this part during all the coding thing. Okay, so After assigning that, we have to say Cn to the stalls and also Cn to the cows. So we know what is the cows and what is the stall. Then we are going to enter the array that we have here. So we enter the number 7, number 4, then we have to enter the array. So we make a for loop from integer I equals 0 to the I less than the number of stalls, of course. So we are always inside this part, as I said. Then I plus plus. So here we are going to say Cn to the location of I. And now we have all our input, and now we can work. But before that, let's sort the array because we need it sorted. Because as we said, it may be like we may have an input that is not sorted. So we need to sort the array to be like this as we want it. Okay. So let's say sort, we say location and location. And here plus stall, which is like the distance that we are going to sort, or the size that we are going to sort. Now after that, let's start with our, let's call it binary algorithm. Okay. So in our binary algorithm, what we need in our binary algorithm, like we have the numbers, which is the gap from 100 to 0. Okay. So 0 is not a possible gap, so it's from 100 to 1, let's say, but let's make it from 0. So we need a left pointer, and we need a right pointer, and we need a middle value. This is mid, and this is left, and this is right. And we need to calculate the mid, then try the gap. For example, we will calculate for 50. 50 did not work, so we'll move the right to 50. Then we will calculate the mid again, and it will be 25. And we will keep doing that until we find the solution. And like if it was not working, we'll move the left or we will move the right. So we need left, and we need mid, and we need right. Okay. Also, we need a gap so we can save the largest gap possible. And we are going to keep updating the gap. And for now, we can say the gap is 0. Okay. And whenever we have a bigger gap that like did work, so we are going to change the gap. For example, let's say 4 did work, so we'll say the gap is 4. Then we find out that 25 is working, so we'll say the gap is 25. And whenever we find a bigger gap, we will going to change the gap. Okay. So back to our code, we have to say integer, let's say left binary. Okay. And left binary should equal to the first one. Like if we back here, like the left binary should equal to this one, to the value of the first one in the array. And like the right binary should equal to the last value in the array. So we are going to say left binary equal to location of 0. And right binary is equal to location of like the last one, which is stall minus 1. And also we need the mid value, which is equal to the, here's stall. The mid value is equal to the left minus right, left binary. No, actually it should be right minus left. So we say right binary minus left binary or you know what, let's add them together and divide by 2, so we will always have like the medium value. Okay, so when we add the right one plus the left one divided by 2, we will always get the minimum, the mid value, which is 50. Okay, so after that what we need is the gap, which is equal to 0. Now we have everything that we need. So let's start our, let's say, binary algorithm. So inside the while, like what is the thing that is going to break like the loop that we started? Okay. So as we said, we are going to check the right and the left, and we have a median. We are going to keep doing that until, let me change the color, like until the left, because we are keep going to update the left to the mid value +1, or the right to the mid value -1. So when the left is pointing to a number, here's the left, and the right is pointing to another number, here is the right, and the left is now bigger than the right. So actually we have checked everything because the right now is less than the left. So like when we move through the algorithm, we will find out that the right and the left, if they exceed each other, then the algorithm is in. Okay. So what are going to say, while the left is less or equal to the right, so here we are going to stop our algorithm. So the first thing, we have the median value, like we already assigned the first one, which is in our example will be 50. So since we assigned the first one, which is 50, we need to check if 50 work or not. Okay. So let's say that like the checker, let's call it like checker starts here. Checker, or let's say assigner, it's better because we are going to assign the cows. Assigner start, and let's write like a code for it. So in the assigner, we need, like in our example, we have number of cows. So we want to make sure that the number of cows are already assigned. For example, when we say 50, we put 1 here, then we move 50, we put another 1 here, then we move 50, we put another 1 here. So the number of cows is 3 that we assign, and the number of cows that we need to assign is 4. So we have to keep tracking the number that we already assigned and with the real number. So we will make a counter. We will call it count, for example, and it's equal. Let's make it equal to 1. Why 1? Because we always assign the first cow here. For example, like in every question, there is no way that we are going to assign like the cow in the second position. Like to give the best answer, we always are assigning the cow in the first position. Then we are going to move for the gap distance. Then we are going to assign the second one. Then we move the gap distance and assign the third one. So always we are going to assign the first cow in the first position. So here we should say the count is 1. We already assigned it, like we have to consider that we already assigned it. And we have to say the current stall is equal to 0, which is the stall that we are on. For example, like when we assign the cow here, we are going to move for 50. Okay, then we assign the cow here. So the current one should be here, and we are going to move 50 from this one and moving 50 steps. And like the first one, we started from here, we moved 50, then we assign it here. Then we change like the current stall, we put it here, and then we moved 50, and now the current stall is here at the last one. Okay. So we have current stall, which starts in the first position, the first assigned cow, and the counter, which is the counting, like a counter for the cows that we are assigning. So from here, we are going to say for loop, which is integer I equals 0. Oh, sorry, it should not be 0, it should be 1. Why 1? Because we already count this, we assign the cow here, so we already check this one. So we are going to move for the next one. So this is like in the array, this is number 0, this is number 1. So we are going to start from the second one, like which is I equal 1, not I equal 0. Okay. Then we have to say like it's I less than stall. Okay. So we are going to move like through all of them. Okay. Then we are going to say I plus plus. Okay. So inside this for, we are going to say if location of I minus location of the current one, like is it bigger or equal the mid value? If this one was true, sorry. So if this condition was true, we have to say the current stall is equal to I. So we assign the cow, then we are going to add for the count. We say count plus plus. So here, like what we did, like we checked if the mid value, which is 50 in our case, is it bigger than the location of the current stall minus the I, which is like I is here, for example. We say 25 minus 0, it didn't work. 50 minus 0, yeah, 50 is equal to the mid. So if it's equal to the mid or even bigger, because maybe this is 51, not 50, okay? So we are going to assign another cow, and we are going to change the current to the new one, and we are going to say count plus plus, okay? So now I guess we finished the assigner. Yeah, nothing more. Let's say assigner and like there's only one thing we have to consider, which is imagine that we are testing a very small gap, which is number 1. Okay. So when we say gap number 1, we are going to assign cow here, then another cow here, then another cow here. Okay. Then the fourth cow here. And also, like depending on our code, because we are going to move through all the stalls, we will find also we are assigning a cow here and assigning a cow here and assigning a cow here. So we assigned the 3 extra cows they are not needed. Actually, this will not like affect our code, but we can make it more efficient, which is if we count 4 cows, that's enough. We don't have to keep going through it because we know that number 1 is working. Yeah, we don't need to keep going. Like we assigned 4 cows. Okay, that's enough. We know that number 1 is working. Let's check another number. So what we are going to add, like a small thing here in the for loop, we should say and count is less or equal, let's say, or no, only less, like of less than cows. So if the cows is like if the count is less than cows, it is going to work. If it is equal cows, like this or equal, it will count 1 extra. So we don't need to count 1 extra. So now this is like exactly right. Okay. So now back to the binary solution. Like this is assigner. It will check if the number that we have used is good enough or not. So what we are going to check is the count that we made. So we are going to say if the count was equal to the number of cows. So what does that mean? That means that the gap, or that means that the left should be equal to the mid plus 1. Also, the gap, we have to update it, is equal to mid. Okay. So what we did here, we checked if the cow is working. So we are going to say gap. For example, if we check number 1 is working. So we'll say gap is equal to number 1. And when we find another one which is bigger than 1, we will change the 1 and we will say, for example, 25. And that's it. So what if the number did not work? We will say like make y binary is equal to the mid minus 1. So if the number is too big for example, if we are checking 50, so the number is too big, so we are going to change it and check another one. But like we are not going to change the gap because 50 already did not work. Okay. So like this, we finished all the algorithms. We only need to print out like the gap that we get. Okay, and we say end line. So let's test this code. So if we try this number, it should print number 3. Okay, we have one issue. Let's check it. So yeah, I just get the issue. So the issue here that we didn't update the mid value. So when we update the mid value each time, like we change the left binary, we change the right binary. So we are going to do the loop again, but we didn't update the mid. So after we update the mid, we are going to check it again, and it should work. Now it's working. As you can see, it did print 3, which is the minimum largest gap distance that is possible.